Today I want to provide you an introduction, a short introduction about the linearization procedure with PCap02. First we start the ACAM evaluation software PICOCAP02 Plus, and then we need to select the device. Usually the devices are labeled with an A at the end. Meanwhile, the other versions can be ACAM internal versions. So in my case, I select here PCap02A. This is what I have the evaluation board connected to, and then say standard to select first of all a standard configuration just to test communication and interfacing to the board. After loading the configuration, I click on Write Config and Start Measurement, and then we see here in the diagnostics window that the measurement values are already displayed. That way I know that communication is working and I can go on with loading the linearization firmware. In my case, the standard evaluation kit with a PCap02 is connected and fixed ceramic capacitors connected to the PCap02 in a floating single mode. So I will explain the linearization generally. We will dive into some details about how to change the sensor configuration and also the temperature sensor configuration later, but let me explain it on a very general level. So for example, if you have a pressure sensor connected and you want to do the linearization, you can go ahead. It's later the same for humidity or even for another application like fill level. What you do is you select by clicking the pressure button here the configuration and firmware which is loaded in the background. There's a message coming up that I'm required to download some e-square-prom data, something where we will come to shortly. You see the data is loaded here, and indeed I just opened the e-square-prom window here, and you see there's a number of parameters already predefined. So this is a start set for the linearization firmware, and what I will do is write that down to the e-square-prom of the PCap02. By this red bulb here, you see if this is illuminated, it's still writing. Once it's like this, the writing process has been finished. After that I can close that window or leave it open and actually say again write config and start measurement to see if there's a measurement value displayed. Two values are of particular interest at first, which are the CI ratio in line 6 and the R ratio in line 7. With the CI ratio, I would expect a ratio around 1 because I have two ceramic capacitors from port PC0 to PC3 on the PCap board connected in single floating mode, but I get here a value displayed around 1.8, so I go to the CDC side to check if I set everything correct, and here obviously the internal capacitor of PCap02 is selected, which I change now to the external one. Now you can see that the CI ratio is around 1 as expected. Also the ports are enabled correctly from 0 to 3, and I have a floating single set with a straight compensation on. So that way I have the configuration adapted to my needs from a sensor setting side, and I will do now the same for the temperature sensor. For this I change to the RDC tab, and you see here the settings available for the temperature sensor. You can either connect a temperature sensor like a PT1000 externally, or you can use the internal aluminium temperature sensor, and the same is true for the reference. That can be an external resistor which should be in the same range as the temperature sensor, or you can select the internal polysilicium reference. I will now change to the internal temperature sensor, since on my board an external temperature sensor is not populated. So what I do is I deactivate the external one and I activate the internal ones. So you see then, according to my setting here, these points are highlighted to illustrate that we're having this path here active. So that way my temperature sensor is set, and I can see here in the line 7 R ratio that I'm getting a value out of it. However, the value for R ratio is not in the range I expect it to be, so therefore I change another setting which is in the parameter window that can be opened by clicking on Tools Parameter. And you see here that there's a rselect 0 and 1 parameter which actually determine the setting of which temperature sensor will be used in the firmware. So this is these flags are input parameters for the firmware. So if I want to use the internal temperature sensor and the internal reference, I actually need to activate rselect 1. Once I'm doing that, you can see that our R ratio is suddenly changing to a ratio around 1, roughly around 1. So this is what I expect. Similarly, to select the ports as input parameters for the firmware, I can adjust that by setting cselect 0, 1, 2. Now in my case it's correctly set it because I selected C1 to C0. And in this case this setting is correct. A coding of this setting will be provided by further documentation of the software. So at the moment this is the right setting for my setup. I can then close the window and actually start finally with the linearization procedure. For that, I go to Tools, Linearize, and another window pops up, which is containing several tabs for doing the linearization. First, I want to talk about the sensor characterization. That means to do the linearization for the capacitive sensor, and then in later we will talk about temperature sensor linearization. In this first tab page, you can very flexibly select the number of calibration points you want to set. So let's say we want to do a sensor calibration at 2 temperatures and over a range of pressure points. So for example 0% pressure, 10%, 20% pressure, and so on. So in this case what I do is right here in the pressure point I'm planning to set, for example, like 0% pressure, like 10% pressure. You give this in as a 0.1 value here, then 0.2 would reflect 20% pressure, 0.3 30, and so on. So I just do that for the whole row until we get 100%. Then next you would set the temperature where you want to take the measurements from. So in my example I would set this to 25 centigrades. And of course I can do the same now for a second temperature, which simply means to add more calibration points and do the same again. So I start here off with 0 and then go up to 10% and so on. And in this case, of course, I want to calibrate at another temperature. That means I set here, for example, 60 centigrades in my example, and do that for the whole row again. Of course, in reality, you won't have exactly always 25.0 or 60.0 centigrades. So in this field, you can actually fill in the real temperature you have at your temperature chamber. So that can be like 25.1 or whatever. So you can flexibly adapt that to reflect the real temperature setting you have. What you do then is to acquire the values directly here with the software. So that means if you set like 0 percent pressure at 25.1 centigrade temperature, then you say acquire, and the actual result from this measurement will be captured and filled in here in the C ratio. So actually this column is reflecting what we are measuring. By clicking in a line, like for example like here, and saying acquire, automatically the C ratio will be filled in here. Now in my simple setup I have simply room temperature and evaluation kit, so the ratio will be more or less always the same when I do this here, but it's only to illustrate the basic principle. Once you have done that with real values at 2 or even more temperatures, then the coefficients of a third order polynomial will be calculated here automatically. So I just filled in the C ratio column some assumed values, and you see then the coefficients are calculated correctly. Once you have the coefficients, you can go back to the ESquareProm page and say refresh with linearization data to import the coefficients calculated here to the corresponding parameters in this window. So you see now that was updated, and after that I simply say write to write this to the ESquareProm of the PCap02, and once this is done, actually the linearization of the sensor, of the capacitive sensor, is done already. So from here all you need to do is, if you like to, is save the file. So the data acquired will be saved to a file, just in case you want to reopen it later. And of course the parameter settings and the linearization, they work always in conjunction with using the firmware. Now in the beginning, when I started the project, the firmware was already downloaded in the background by loading the project. For a sensor to have the firmware permanently, of course the firmware must be downloaded to the OTP. I will just demonstrate how this works without doing it, because the OTP can only be programmed once, of course. So if you want to write down the firmware, it would be memory OTP SRAM. So we have now content in the SRAM anyway, because this is where the project downloaded the content to, so you can see that here. By reload file you get the actual hex file, which is also displayed here in this window, and what you do then is writing this to the OTP as well as the configuration. So these are the two steps you need to do to burn the firmware permanently to the PCap02. By doing this, together with the ESquareProm parameter you downloaded before, your sensor together with PCap02 is then fully linearized, at least in terms of the capacitive part. If you want to now linearize the temperature sensor on top, I will show you in the next steps how to do that. For the temperature sensor linearization, we go to the next tab here, and actually we have more or less the same page as we had with the sensor characterization, where we can select the number of calibration points for the R ratio. So we selected previously the RDC to be the internal one, so the aluminum temperature sensor, and having also the internal polysilicium reference. So here you can set several temperatures, like from 10 to 50 in this example, and by clicking in the corresponding line and saying acquire, also the ratio will be acquired. And you see that by this also the coefficients of a polynomial are calculated here automatically. So this way you can characterize your temperature sensor. One note here, at the current state of the software as of April 2013, we have here a little limitation still, which is you need at least 4 calibration points. So if you go further down, you see with 3 calibration points the coefficients come to 0. This is due to the mathematical calculations in the background and will be fixed soon. However, at the moment I just wanted to note this, that you need at least 4 temperatures to get here a calculation done. Once you have done that, you can also download these coefficients to the ESquare So if I go back and say again refresh with linearization data, you see that the data is imported here. The values actually don't make too much sense right now, but this is the same as before. I don't have real measurement values here, only some ratios for demonstration. I probably would need to adapt this slightly to get real coefficients out of it. So this looks better. And yeah, this is how it looks like more or less. And then actually we have the same procedure as before by saying write to the ESquare together with the capacitance coefficients we had determined earlier. We have now both the temperature sensor and the capacitance linearization parameters all in the ESquare. An alternative way to do the temperature linearization with a more simple approach is actually to take the standard values for the internal temperature sensor. I will obtain them again by loading the project quickly again. So let me see that. So now we see there's a TC1 and TC0 value given here, and they are a simple linear approach linearization for the internal temperature sensor. So you can use this as a basis and again write it down to PCap02, and after that you see already that here the theta is displaying the temperature, is more or less showing room temperature. And all you need to do then would be, when you do the capacitance linearization anyway at any 2 temperatures, for example like here 25 centigrades and 60 centigrades, you use that one and 2-point calibration tab, and when you are at 25 degrees centigrades you say acquire CCP1, and you see it's automatically filled in here. And when you then at the next temperature, in my example 60 centigrades, I say acquire CCP2, and the second ratio is filled in here too. That way the standard coefficients used for the internal temperature sensor linearization are 2-point calibrated. Of course I need to refresh the ESquare prom parameters again to match this new calibration, and you see then TC3 to TC0 is adapted accordingly. So that way you can also do the temperature sensor linearization in a more simple approach. Now the linearization of both the capacitance sensor and the internal temperature sensor is done, and you have the full set of parameters determined, can download them, and finally your sensor is linearized. Of course you can save all the contents, so you can save to file here, and you can also of course save the whole project. One remark at the end, the general setup which was loaded with the project, or which can be loaded by using the pressure button here, is like a standard setting, which is a good starting point for most sensors. However, of course you can adapt all the parameters you like for example the averaging rate, timing settings and so on, to your needs, and use that configuration to do the linearization or to generally run your sensor. Whatever you do, you can then at the end save the whole project. So if you close the software, you will be asked anyway, or you can alternatively say save project. So I say here save project, and can then select here a path wherever you want to save it in, and give in a name for the project. I just save it as a test project, say save, and then you're good for loading the same project the next time again. Thank you for listening to this screencast, and you can write an email to support@acam.de for further questions or give us a call. Thank you.